Section 6.6, Systems of Linear Inequalities. So in the previous section, we talked about graphing linear inequalities. Now we're going to talk about solving systems of linear inequalities through graphing. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. Solutions of a system of linear inequalities are all of the ordered pairs that satisfy all of the linear inequalities in the system. So to be a solution to a system of linear inequalities, the ordered pairs or ordered pair has to satisfy both or all of the inequalities in the system. So in this first example, we want to test and see if the point -1, -3 is a solution to this system. And in order to do so, we have to plug it into both inequalities. So remember, we have x and we have y. So to plug it in here, we've got -3 is less than or equal to -3 times -1 plus 1. On the right side, -3 times -1 is 3. 3 plus 1 is 4. So in this case, is -3 less than or equal to 4? Yes, that's a true statement. So it works for the first equation, or first inequality. So let's see if it works for the second. -3 is less than 2 times -1 plus 2. So 2 times -1 is 2. -2 plus 2 is 0, so we've got -3 is less than 0, which is also true. Since both of these are true, that means that -1, -3 is a solution. All right, we're going to do the same thing in this example. We've got our x and our y, so we're going to plug them in. So in this case, we've got 5 is less than -2 times -1 minus 1. So -2 times -1 is 2. 2 minus 1 is 1. So you've got 5 is less than 1. Well, that's not true. That's false. And we don't have to go any farther, because if one of the inequalities ends up being false, the entire thing is false. So this means that -1, 5 is not a solution. Third example, same thing. We want to test the point 0, 0. So in this case, we're going to plug in 0, 0. So we've got 0 is greater than -0 plus 1. So that means 0 is greater than 1. Well, that's not true. So since it's not true for the first inequality, it's not going to be true for the entire system. So that means 0, 0 is not a solution. All right, so we're just testing points in the first part. To show all the solutions of a system of linear inequalities, we want to graph the solutions of each inequality. The solutions of the system are represented by the overlapping shaded region. So we're going to shade for both inequalities and then see where the shading overlaps. That overlap is where your solutions are for the system. So in the first example, we're looking at trying to solve the system of linear inequalities that has the inequality y is less than or equal to 3 and y is greater than -x plus 5. So let's graph the first one. All right, so for the first one, we've got y is less than or equal to 3. So we know we have a solid line at y equals 3. So y equals 3 is here. So it's a horizontal line at 3. And it's less than, so we're shading underneath. So we're going to shade underneath, so we'll just make a few lines here to show the shading. All right, so we're shading underneath. All right, next one, we have the equation y is greater than -x plus 5. So we start by plotting our y-intercept at 5. We're going to apply our slope, down 1, right 1. Okay, so we've got our slope. For this problem, we want a dashed line because of the symbol. And so dashed, we'll draw a dashed line. All right, and so for this one, it's greater than, so we're going to shade above. And so when we shade above for this one, we should notice that our overlap takes place right here. So this is the solution area to our inequality. This is where the two shaded regions overlap. All right, next example, we have y is less than or equal to x plus 1, and y is greater than 2. So graphing the first one, we're going to have a solid line. And so we start by plotting the y-intercept at 1, applying our slope. Up 1, right 1. So we plot our points. It's going to be a solid line, so we just connect our dots. And because the symbol is less than or equal to, we're going to shade underneath. So we're shading underneath. For our second line, we've got y is greater than 2, which is as a dashed line. And it's a horizontal line at 2. It's a horizontal line, dashed line at y equals 2. And since it's greater than, we're going to shade above. As we do this, we should notice that our overlap of the two shaded regions is right here. So this is our solution area. In this example, we've got negative 3x plus 2y is greater than 2, or greater than or equal to 2, and y is less than 4x plus 3. So to solve this one, we've actually got to first rewrite this first equation. So we've got negative 3x plus 2y is greater than or equal to 2. So I've got to write it in slope-intercept form. So I've got to move the x. So I add 3x to both sides. I've got 2y is greater than or equal to 3x plus 2. Then I divide by 2. And so my equation becomes y is greater than or equal to 3 over 2x plus 1. And this is what I want to graph. So I start by plotting my y-intercept at 1, applying my slope up 3 over 2, up 3 over 2. Down 3, left 2 to go the other way. And so this is my solid line because of the greater than or equal to symbol. And because of the symbol greater than, I'm going to shade above. So I'm shading above my line. Now I'm going to graph the second one. Y is less than 4x plus 3. I put my y-intercept at 3, and I apply my slope. Up 4, right 1. Go the other way, down 4, left 1. Down 4, left 1. This should be a dashed line because of the less than symbol, so I'll dash the line. And so for this one, I want to shade below because it's less than, so I shade on this side. And I notice that the point where the two graphs overlap is just right here. The two shadings overlap right there. And so this is the solution to my inequality. Next one, let's graph the first inequality, y is greater than x minus 7. Plot your intercept at negative 7. Apply your slope, up 1, right 1. This has a dashed line because of the greater than symbol, so we just dash the line. And then the symbol is greater than, so we're going to shade above. So it's all of this region here. Okay, so now the next one, we have 3x plus 6y is less than or equal to 12. So in order to graph this, once again, I have to rewrite it in slope-intercept form. So I've got to solve for x, or solve for y, sorry. So I move the 3x by subtracting. So I've got 6y is less than or equal to negative 3x plus 12. Then I'll divide by 6. So I get y is less than or equal to negative 1/2 x plus 2. I'm going to plot my y-intercept at 2 and apply my slope. Down 1, left, or down 1, right 2. Down 1, right 2. Down 1, right 2. Then I go in the opposite direction to get the back half of my line. This is a solid line because of the less than or equal to symbol. So I'll connect my points. And now I'm going to shade underneath because of the less than or equal to symbol. And I should notice that the overlap of my two shaded regions is this region here. In the next problem, we're going to go ahead and graph the first inequality, y is less than or equal to negative 2x minus 4. And it's going to be a solid line. So I start by plotting my intercept at negative 4 and applying my slope. Down 2, right 1. I need to go the other direction, so I go up 2, left 1 until I have enough points to graph my line. So once again, this is going to be a solid line. And I need to shade underneath because it's the less than or equal to symbol. So I'm shading on this side of the graph. Then I want to graph the second inequality. Y is greater than negative 2x plus 5. This is going to be a dashed line starting with your intercept at positive 5, applying your slope of down 2, right 1, down 2, right 1, down 2, right 1. So we have a dashed line. Because of the symbol, we're going to shade above since it's greater than. And so what we should notice here is that the two regions never overlap. So what we run into here is that there's no overlap between the two inequalities. So this is no solution. All right, let's try this one as well. We've got y is less than 3x plus 6, so a dashed line. Start from your intercept at positive 6, apply your slope. Up 3, right 1, we can't do that, so we'll go down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1. It's going to be a dashed line, so we draw our dashed line. It's less than, so we're going to shade underneath. And then we graph the next one. Y is greater than 3x minus 2. We plot our first point at negative 2. Apply your slope, up 3, right 1, up 3, right 1, up 3, right 1. This is going to be a dashed line as well. And for this one, we're going to shade greater than, so we shade to the left of the line. And we should notice that the two overlapped regions, or the two regions overlapped. And so the overlap between the regions is just the space in between. And so the space in between here represents your solution area. All right, in the next example, we want to write the inequalities that represent the graph. And so that means we have to write both inequalities. So let's just focus on one at a time. Let's start by focusing on just this inequality that's represented here. So the first thing I notice is that the intercept for this line is at 2. And then if I count, I should be able to indicate that my slope is down 2, right 1. So that means I have a slope of negative 2 over 1, or just negative 2. So if I want to write this as an inequality, I'm going to say y, and then I have my slope, negative 2x plus 2. But I have to then determine what inequality symbol goes in between there. Well, it's a solid line, so it's going to be the equal to. and it's shaded above the line, so that's greater than. So we shaded on this side of the line. All right, then we're going to look at the other line. This time we're going to look at this inequality. The inequality, that inequality has an intercept, y-intercept of -2. Its slope would be up 1, 2, 3 over 1. So it's going to be a positive 3 over 1, or just 3. So we do the same thing. We set up our equation, y 3x minus 2. Then we determine what inequality symbol goes in between the y and the x values here. Well, it's not the equal to because it's a dashed line, but we do know that they shaded on the right side of the graph or underneath it, so that is the less than symbol. So this is our system of inequalities. Last one, same idea here. We want to write the two inequalities that represent this system. So let's start with this nice vertical line here. Well, we know that most vertical lines are x equals a number. This is no different, except we have to make sure we use the right inequality symbol. So we know that this inequality crosses at x equals 1. So we're dealing with x and 1. And we have to figure out, is it greater than or less than? Well, in this case, they shaded to the left of the graph, which would be the values less than 1. And it's a dashed line, so we're good to go. The second graph is this dashed line here. And we know that it has an intercept of 3, a y-intercept of 3, and its slope, if we count from this point to this point, is down 3, right 2. So that's -3 over 2. So we set up our equation, or inequality, sorry. Y, we don't know the symbol yet, -3 over 2x plus 3. Well, it's a dashed line, so we know it's not the equal to, but we do know that they shaded underneath it, so that would be less than. So these two inequalities represent your system for this particular problem.